Okay, we're ready to get started? Here we are, the start of week 3. What's a week from today?
The quiz.
The quiz, everybody knows. All right, you know the quiz is a week from today. Oh, well, okay. We open up week 3 then. There it is. Week 3 instructions. What PowerPoint slide should I study to prepare for this quiz, especially those multiple choice questions? Let's just go to the instructions and look. Every week it tells you exactly which slides you should be studying. Just go to those weekly instructions. Because those are the slides I'm using to write the questions. Textbook, what textbook pages should we be reviewing to prepare for this quiz? There they are on the instruction. How many assignments do we have this week? 3, very good. Number line, written, Excel. We're coming to the end of the number line though. We're heading to, after the quiz, it's gonna be like probably just written in Excels. The number line was just an exercise that we're doing to prepare you for all the calculations we're doing in the future. But all these calculations we're doing are very similar to what we're doing right here. When's homework due? A week from today. So as you walk in to take the quiz, you're dropping your homework. Wait a minute, is it due? Did I say never on this one and I forgot? I better go to the, where's the syllabus? Did I forget it? Never. Oh, did I really do that? I did. I made that change when I realized we didn't have a grader at that. So you don't even have to hand in this week's homework? Man, you guys better take good notes. I'll tell you what I'm still gonna do though. I wrote homework assignments, not realizing you didn't have to hand them in. These are brand new. I changed questions from the past. So I'm gonna post answers. I might as well post them tomorrow, I guess, right? So you can use them to study for the, oh no, wait, we got a Tuesday lecture. So I'm gonna post the answers right after Tuesday's lecture. So you have all the answers to this week's homework to study to prepare for the quiz, okay? And by the way, you wanna have the answers to every week's assignments open on your computer before you turn off the internet, before you start the quiz, so you can look at them while you're taking the quiz. You realize that, right? Everybody realizes? Those are gonna be the key to the problems, is having the assignment answers, your in-class and your regular assignment answers all open, ready to go. You're gonna look at a problem and go, oh, that was just like week 2's homework. Open up week 2's homework, and apply the logic that you did on week 2's homework, there. Should you use the homework that you handed in, I passed back? Probably not. You know, I would use the posted answers, because that way you know the details all there, step by step how to solve them. Go ahead.
Are we allowed to use our own computer?
You are allowed to use your own computer, but then you can't use this computer. It's one computer. But what I would do is have everything off of Canvas downloaded already on your computer, ready to go. And if you're not using your own computer, use a flash drive, because when you walk in Thursday, there's gonna be a seating chart up there. You're not sitting next to the people you're sitting with right now. I'm memorizing where all of you who you're sitting next to right now and trying to make sure you don't sit next to them while you're taking the quiz or the final exam. By the final exam, for sure you won't be sitting next to someone. Quiz 1, you may accidentally be sitting next to someone, only because I can't remember everything. Let me get my camera out. So, I gotta change the instructions. I can't believe it. Let's do it right now. Darn it. When's it due? Shoot, I'm gonna put in capitals. There. I gotta highlight it. Right? No way I want to get confused. I'll post this tonight. I'll replace the instructions that are there right now with this one, so nobody thinks that this homework's due. And I'll remind you on Tuesday, because I forgot. There we go, let me save this. Homework's due never. Wow, man. I want to tell you, someone from 302 came and visited me at 2 o'clock last week, and she showed me what you guys have ahead of you. Wow. Wow, you are not ready. Let me tell you that. How long did this homework assignment take you, would you say, more or less than an hour?
Less.
Oh, you are not ready for 302. She showed me the first homework assignment they had to do. I would say it looks like 4 hours, at least 4 hours. I just can't believe it. I was shocked. And then I said, you know, I said, who's the professor? And she told me who the professor was, and I said, well, can you take someone else? And there's like only one other person teaching one other section, that all the other 4 sections are just this one professor. So you guys are, I need to beef up your homework or you're not gonna be ready. You're going from a 1 hour or less homework to a 4 hour, and you're gonna be freaked out. That's not the way to prepare you? Tanisha, what? No? No, you're saying not beef up this homework? Just keep warning you? Okay, just keep warning you. Okay, all right. And then to go with a never, that's not preparing you for 302 at all. That's like, I let my guard down here. Shoot, darn. All right, let's just keep going though. We gotta keep rolling. So, the first assignment I wanna point out, let's see, I don't wanna jump around here. Oh, wait. I wanna refresh your memory on something. These rents. Remember this story, right? I don't have to review the story, do I? 70 rents up there. I went to this slide specifically because this is from like week 1s. We add them all up and divide by 70 to get the mean, right? 490.80. Look at this bell curve. 490.80. Now, we also, I can't remember what slide it is, I forgot to write down the slide number. We also found the standard deviation. Oh, it's way up here, I forgot, that's right. We didn't, it was given right there. There it is, right in the middle. I got my pointer right underneath it. 54.74 is the standard deviation of this data. So look what I did. I added 54.74 3 times, and I subtracted it 3 times. So there's our bell curve, and there's the numbers. Now, right now, we're now transitioning from doing the, what is this called again, empirical rule? We're transitioning from using the empirical rule to do estimates, and even though I showed you already, we're now, from now on, calculating the actual Z and looking it up on the Z chart. So we're transitioning to this. And this is gonna be on your quiz, without a doubt. This is so important. This is like this is the building block. What we're learning today is the building block for everything from 301 and 302. Any statistics you'll have the rest of your life. This is the building block right now. So, what we have to do today is figure out, can we use any number between these numbers and be able to calculate the percent of the area underneath the bell curve, either to the left or the right. Now, I don't know if anybody remembers from, this is like 2 or 3 lectures ago, but when you have a question that's asking for a probability and says blankety blank or less, it's asking you to find the probability of some number on the number line to the left, right? But if the question says, what's the probability of some number or more, it's asking you to find the probability of some number on the number line and to the right. What is that extra step we have to do when using the Z chart if we have a question that says, or more? We look it up on the Z chart, and then what do we have to do? Or if it says, or more. Anybody remember? No one remembers, please.
You do like 100 minus the number.
1 or 100, depending if you have it as a percent or a decimal. 1 minus the decimal you just looked up on the Z chart, or 100% minus the percentage you just looked up on the Z chart, whichever way you're looking at them. But yes, you got to do that last step, but only on questions that say or more, or greater than, or is trying to get you to find the probability of some number to the right. That's the extra step. That's where most of the points are lost on the first quiz, for getting that extra step if the question has a or more. So, now, let me introduce you to the equation again. Right there it is, but this is an abbreviated equation just for the first couple of weeks, for the next couple of weeks. We're heading to the real equation, which is right here. So the abbreviated equation you're looking at right now is this one on the left, and I'm going to put it in words. X is whatever number you're being asked to find the probability of. That has to be on the left in the numerator. Let me say that again. Whatever number you're being asked to find the probability of has to be on the left in the numerator, the X, minus the mean. And you've got to put that in parentheses. Even though you don't see it in parentheses here, that numerator must come first before the divide. There should be parentheses in that numerator. So it's whatever you're being asked the probability of, which we'll call an X, minus the mean in parentheses. That's first. Divided by the standard deviation. That gives you some number between negative and positive 3, usually. It could be a number way off the chart. That happens. But for this class, this calculation will turn out to be numbers somewhere between negative and positive 3. And then you're expected to figure out what that amount of area is under the bell curve, to the left or to the right. But we're heading in just a couple of weeks to where we're expanding this equation to the real equation, which is the number you're being asked for minus the mean, just like that one. But instead of being divided by the standard deviation, it's divided by the standard deviation over the square root of the number in the sample size. And that has to be divided into the standard deviation before you divide into the numerator. But here's what's happening. Today and on Tuesday of next week, and in the questions on the first quiz, they're all about what if we only pick one sample? Hey, here's a whole bunch of apples. What's the probability this one you pick out is got 3 holes in it, or I don't know, 3 flaws? What's the probability it has 3? How many apples did I pick out of all these apples? 1. So what happens is the number in the sample is a 1. The square root of 1 is 1. The standard deviation divided by 1, that's why this formula is what we're using to start with, because the sample size is only going to be 1 for all these questions. In a couple weeks, the sample size is going to be 30, 12, 100, and we're going to this formula because that changes that denominator when we get in a couple of weeks. So for this first quiz, we're going with this nice easy formula because we know the question's only going to say, hey, we got, oh, I'll tell you what it's going to say. Let me get those rents again. Where are they at? Come on. There. Okay, ignore the stuff on the top. There's the rents. Matter of fact, they're in order from smallest to largest. Hey, I took 70 rents, wrote them on a piece of paper, folded it in half, and I just put it in this box. And I covered it up, and there's just a little hole in the top here. I want you to reach in and randomly select one of those 70 rents. Here it is. What's the probability that you select 445 or less? What's the probability you're going to select 445 or less? And we would go 445, because that's the one you're being asked about, minus 490.8. Figure that out, then divide by, I didn't write it down. What's the standard deviation? 54, I gotta find it again, I should have wrote it down. Again.
I think you passed.
Oh, I just passed it? There it is, 54.74. Divided by 54.74. All right, so we're gonna try one now. Let's just do it. But here we go. I want somebody to pick a number between 326.58 and 655.02. Don't even give me pennies though, just give me a number. I heard somebody say something.
400.
400, you ready? 400 or less or 400 or more? Less, here we go. The question says, you just got your quiz. It says here are there's 70 rents. Here are 70 samples, 70 rents. We got them all in a hat. There's a pile of rents there. And what's the probability that we're gonna pick one out of the 70 and it is gonna be $400 or less? The one we picked out is $400 or less. So here we go. 400 minus 490.80 divided by 54.74. And what does this equal? Z. I put a little line there so it doesn't look like a 2. In programming, you always put a line on your Z's to distinguish it from a 2. So that's our Z. Here we go. I know that's going to be, well, this is kind of easy really because we use a nice round number 400. So I'm going to show the math. These two subtracted is minus 90.80 divided by 54.74. Somebody's beat me to it. 90.8. I'm going to make it negative. Who knows why? Divided by 54.74. All right? Equals. Here's our Z. Negative 1.658. 658. What's my fourth digit? 658.
8.
Very good. Very good. I'm not catching you guys. All right. All right. 88. But Our z-chart only goes 2 digits to the right. We're gonna go to that first column to negative 1.6, but then which column do we go to? Because the second digit is gonna be what? What should this digit be? Negative 1.6 what we're looking up on the z-chart? There it is. Here we go. You guys better have that z-chart downloaded before the quiz starts and open and ready to look at. Negative 1.6, there it is. It's at the very bottom of your screen right there. Hang on, let's make this bigger. I want to make this bigger. I want to see this. Oh, that was too big. Okay, here we go now. What did I say? Negative 1.6. There it is. I got it right there. The last one. I'm going over to the second digit of 6. Going over, I see point what? 0.0485. There it is. 0.0485. Now let's look at the line. Negative 1.66. Here's negative 1. Here's negative 2. We were here's negative 1.5. We were right in this area right here to the left. So I'm just going to kind of, this area all in here comes to, should I make that into a percentage? What percent would this convert to? 4.85% of the bell curve is from there to the left. There's a 4.85% chance that if we draw one out of this hat of those 70 rents, that the number we just drew is $400 in rent or less. Ready? Hey, the mean of all these 70 rents is 490.80 with a standard deviation of 54.74. We got the 70 rents in this hat. You're about to pull one out. What's the probability that that one you just pulled out of that hat is $400 or more? Oh, I knew what I was saying. So look, I'm going to use the decimal. 1.00 minus 0.0485. Let me add the O's here. Equals, well, what's the opposite of that? 0.9515, I think is the opposite. Anybody confirm? What's the opposite of 0.0485? Take 1 minus that. Someone help me. Come on, where's my calculators?
It's right.
It is right? Yeah. So there is a 95.15 chance that we select one out of there is 400 or more. From this point over, that's most of those rents are in that hat. Matter of fact, 95% of the rents in that hat are 400 and above. And only like 5% are 400 or less. My question for you is, if I give you any number, can you calculate the z's and look it up on the z-chart? I want everybody to pick a different number. Don't look at your left, don't look at your right. I want you to pick a random number between 326, don't use 400, we're done with that one. Use a number, don't put pennies on it. And between 326.58, or let's say 327 to 655, don't use the same number as anyone else. Don't look to your left, don't look to your right. Pick a number, do the math, get the Z, look it up on the Z chart. Right now, everybody. I want everybody just to do one, and then I want to see if you got it right or wrong. Huh? Yeah. Yeah. Are you gonna have access to the Z chart? So you need me to move that one. Tell me if you need me to move that one. Where to move it? Oh, I'm sorry. He asked a question first. So I'm going to him. Go ahead. 327 and 655. Any number between 327 and 655. The one, between the highest number and the lowest number on that. She got it? You good there? Thanks. Oh. Oh, because it was negative 0.166. So the next, whatever the second digit is to the right, is what column you use. So if that were, and then we had to get to 2 digits. Yeah. Yeah. Now, what if that were 7? You go all the way to the 0.07. If that were an 8, that second digit, maybe go all the way to 8. Yeah, that's right. If there were 7 on there instead of 6. That's right. You're welcome. So all based on that second digit to the right, as to which column you use. You got an answer? You done? You looked it up? How'd you look it up? Where's the Z-chart? Oh, look at you guys. Everybody have a Z-chart? Does anybody need me to make this smaller or bigger because you don't have a Z-chart in front of you? Is there a Z-chart in your book? You guys don't even have your book in front of you. You know it's open book too on that quiz, right? Just making sure. All right. Hang on, do you need me to move it up or down? Anybody need more numbers? You want to see the positive? Okay, let me go to the positive. This is some number or less. Don't do the or more, do the less. Back up, back up. Hang on. Let me go to back to the negatives. Okay, I think we see almost all the negatives there. You just don't know which columns. Count it there. Now you can see the columns. Oh, no, you can't. Darn it. Hang on. Now you can see the columns. Okay, how many people are done? If I got half the class done, we got almost half. Just give another minute here. Keep an eye on time. Okay, who's not sure they got it right? Who's not positive that they did it right? Who's unsure? Give me yours. Who is it, Jason?
Yes, Jason.
Yeah, give me your number. What number did you decide to try?
Number I tried is 380.
380. You ready? 380. So he should have, the only difference between this one and what he did is 20 off. So this is 20 lower, which will make this 20 bigger. So you should have gotten a negative 110.8. Does that sound right? Where's Jason? Did you get a negative 110.8 for the numerator?
Yes.
Divided by 54.74?
Correct.
Okay, hang on. Let me divide it, see if you got the right Z. So 110.8, you have a Z already? Who just said that? And what, hang on, divided by 54.74. It's going to be negative, but here it is. Negative, so in your case, negative 2 point, I'm only going 2 digits, 02. Did you get negative 2.02?
Correct.
Now let's look up negative 2.02. So 2.0 is right, where's my pointer? Right there. And the next digit is a 2. So I gotta go to the column where there's a 2. Did you get 0.0217?
Correct.
Well, you thought you had it wrong and you had it right. Did everybody see how easy that was? You want to do one more? You want to do one more? Corey?
Sure.
Is it Corey?
Yes, sir.
Corey, tell me what number you use.
I use 380.
What? 380? That's the same number.
I know, right?
So let's figure out where you got it wrong then. Did you at least get 110.80 on the numerator, negative 110.80?
I did negative 110.8.
Okay, then did you divide that by 54.74?
Yep, I got 2.0241.
Yes, now you just have to look up negative 2.02 on that chart. So look at my pointer right now. See the negative 2.0 right where my pointer is right now?
Right.
The next digit is a 2, so I got to go across to that 0.02 at the top.
Okay, gotcha.
Got it? So let me go across and then one right there, and now the answer is 0.0217.
Okay.
It's all based on that second digit as to which column you use, guys. Go ahead. 669?
655.
655? Right here? Well, that's almost right on the 3. I don't even need to do the math. Let's look up the 3 right now. It's really close to 0.0013, so let me guess. You probably got 2.9 what? 2.99, so I gotta go all the way over. Hang on, my calculator's in the way. Did you write down 0.0014? Is that what you got or not?
I got 0.9989.
Oh, I'm sorry, it's positive. My bad. Hang on. Let me get you 2.99 positive.
9996.
Did you get 0.9986? You did it right. If you got 0.9986, is that what you got?
8996.
Oh, what do you mean? Oh, you didn't do it using the Z chart?
2.9996. 3 9s and a 6.
Yeah. Oh, so you went to 3.0. No, yeah, you went to 3.0. So you got your answer then you looked up was 0.9987. Did you use 3.0 when you looked it up? Or because you can't look up 2.99 if the next digit's also a 9. You had to look up 3.0. Because you got to round the next digit. You guys, everybody see what I'm saying? You can only go to 2 digits to the right. So if you're rounding that 9 and the next one's a 9, this is going to round to 3.00. There you go. All right, we got a couple of things real quick. Something new on Excel we haven't seen yet. This is very similar to max and min, but there's advantages to large and small. These are 2 new Excel equations that you're learning right now, the functions. large, here's the difference, equals, large, parentheses, B8 to B25 is that same data when we use max or min over here. Let me scroll up a little so you can see it all. Even the AB and that CDE, same data. But look at what it's doing, comma, 1, there's the difference. When you put a 1 there, that comma 1, you're telling Excel, I want you to find the number 1 largest number. Just like Max does, same answer. But you can switch this to a 2. Now you're telling Excel, find the second largest number. That you can't do with Max. Max does one purpose only, find the largest number. With large, you can find the second largest number, third largest number, fourth largest number, and it goes on and on. That's the advantage of large. Let's go to the other one now. Oh yeah, I gotta put this back for the other class. There we go. Small, very much like min. The purpose of min is to find the absolute smallest number, but small, you can find the smallest number, or the second smallest number, or the third smallest number by just changing that last number. That comma and that last number is telling Excel which small number do you want. The smallest, the second smallest, the third smallest, the fourth smallest. So does everybody see the advantages to large and small compared to max and min? Believe me, you're going to get to some problems where you need to use the second largest or the second smallest. This is just another example here. Oh, here's the second one right there. Large, B8, B25, comma 2. Here's the second smallest, B8, B25, 2, comma 2 for small. So there's the 2 new Excel functions. Now, here's the awful part of today's lecture. How are we doing on time? We're doing fine. This is preparing you for some of the multiple choice possible questions that you may see in your future. And one of the most important things you need to make sure and understand is the difference between discrete and continuous data. For all those following along, I'm on chapter 5 PowerPoint now, and I'm on slide 2. So we're not on chapter 3 PowerPoint, we're on chapter 5 PowerPoint. Discrete versus continuous. All right, you ready? Here's how I remember whether I'm looking at discrete or continuous data. Discrete data doesn't have any data with decimal numbers to the right of the decimal. Continuous data has a bunch of data with numbers to the right of the decimal. Or has data that has numbers to the right of the decimal. So if I said, here's my data, 5, 2, 1, 5, 3, 6. Discrete or continuous? Did you in that data? Discrete. You don't see 5.399, 1.674. That would be continuous. Now, you ready? You're not going to be given data with numbers. You're going to be given descriptions of you collecting data, and you got to then tell me, are you collecting discrete or continuous data? For example, are you ready? Each day for the next 5 days, we're going to be here from 10 to 11 in the morning to count how many people walk through that door. Try to imagine this. So I got 5 days of data now. Tell me what could be the examples of what I collected on those 5 days. Day 1, what could have happened? How many people walked through that door? 25. Let's go to day 2. I collected data for an hour. How many people walked through? 5. Day 3, how many people? 18. Day 4. 20. Day 5. 30. Did everybody hear those answers? Nobody said 30.32. Nobody said 5.67. There is not any chance we're going to collect data with decimals in that scenario. A half a person's not walking through that door unless it's a magic trick of some kind. Right? 2/3 of a person's not. We're not going to collect any data that has decimals. You're not going to be told that. You've got to read the scenario, imagine you're collecting the data, and then ask yourself, would I ever use a decimal in this case? Are you ready? We are working at a restaurant. It's a self-serve restaurant. Help yourself. You come up to the cashier with your plate of salad, and it gets weighed. And your price is based on the weight in ounces. You ready? Imagine you're bringing the salad up. You give it to the cashier, puts it on the scale. Give me an example of what in ounces that salad might weigh. 5.6, 7.2. I couldn't hear you. I think that's what you said. 7.2, 5.6. Another example. 2.9. A light salad, light eater, whatever you said. But notice, That salad could be in ounces, between 2 and 3, between 3 and 4, that you expect there to be point something. Or if I said pounds, you'd go, oh, 0.2 pounds, 0.1 pound. Probably no one's buying a pound of salad for lunch. So the point I'm trying to make is, you're gonna be told a story, you gotta imagine you're collecting the data, and you gotta then tell me, is it discrete or continuous data you're collecting? The salad example was continuous data because it had the decimals to the right. The people coming through the door was discrete data because there's no way we would use decimals in that case. A couple more examples I think are on here. Here we go. You have to go and make phone calls to random family houses, and you gotta ask them how many dependents are reported on your income tax. Here's the answers you're gonna get. Think about it. 2, 1, 0, 5, right? They're counting how many kids or whatever they put on their taxes as dependents. No one's gonna say 2.3. No one's gonna say, I've got 5.5 children here. Only have half a child still left on one case. No one's gonna say that. That's how you know you're collecting discrete data. The question on the quiz is gonna say something like this. You're collecting the distance in miles from home to the store site from different homes. From a home to a store site from different homes in miles. Why is that continuous data? Because the answers you're gonna measure could be 4.2 miles. It's not gonna be right on 4 miles or right on 5 miles. Go ahead.
But if it was right on like 4 miles.
Yeah, but you're gonna imagine you're collecting it from a bunch of different homes.
Okay.
So there's no way every one of them will be exactly a 4 or exactly a 5, right?
So the rule is basically if there is a decimal, then it's.
If you could have a decimal involved, then you know it's continuous.
Okay.
But if you're counting people coming through the door, there's no way you're gonna have a decimal, right? That's how you know it's discrete. Actually, it's a lot easier to recognize discrete, and if you're saying, I'm not sure that's discrete, go with continuous. That's the harder one to recognize.
Okay.
All right, here we go. You're gonna make phone calls, and you're making a chart here. You're giving them a 1. If the person answers, you're gonna say, can you tell us about if you have a dog or a cat, please, or either or both. You're gonna mark a 1 if they say no pet at all, a 2 if they say a dog only, 3 if they say cat only, and you're giving a 4 if they have eat both, however many, but they have both in the house. The reason you're collecting discrete data is you're not giving anybody a number like 1.2. You're either giving them a 1, 2, 3, or 4. There's no other numbers in between those numbers. You could be writing down, making these phone calls, asking people if they have a cat or a dog. That's how you know it's discrete data. Does everybody understand what to expect on the quiz when it comes to discrete or continuous data? Go ahead, ask your question.
So what if like the units were in halves? Right, but there's no
Give me an
way-
example.
I can't think.
I can't think of one either. I don't know who this
No,
question.
but it was always like 1 or 1.5 and then 2 or 4.5 like. you
Okay,
guys-
yeah, how about this? You're at a restaurant and you said, every day for lunch, I'm gonna write down how much was charged on everyone's charge card for the next 5 days.
Okay.
Okay, what kind of numbers are you gonna collect in dollars from getting those charge card receipts? Tell me the numbers.
Could be anything from
Give me an example.
10.23.
He's already jumped to a number that to the right of the decimal, and I thought he was gonna say $10. But then I'd say to someone else, and they would have said $12.50. Soon as you can imagine that one of the answers could have a decimal to the right of the digit, you know it's continuous.
Okay.
That's it. But if you say to yourself, okay, every one of these charge cards are gonna be right on the dollar, $10, $9, $8, and there's no way there could be pennies involved, then it's discrete, but that's not gonna be the case, is it? You can imagine that the charge cards are gonna have pennies involved. So any of those that have halves, they're gonna be continuous. Go ahead.
We have like a question where it's like the means, so say we're talking about the classroom, how many people walked in, it would be like, we're taking as the populations a year, it's like, we're talking about the averages of each week. Are there any like trick questions like that?
No, because that would be tricky. He's trying to say, we're gonna have our data be the mean of how many people walk in, and you do then get into decimal points, and it does become continuous data. But this is all about the raw data being collected, not any calculations being done at all. This is just identifying the raw data being collected. So the question, when you have to identify whether it's discrete or continuous, is gonna be about you collecting raw data, and you have to imagine, am I writing down numbers that are integers, or could there be decimals involved?
So grades with letters are discrete and grades with numbers are continuous.
Well, what do you mean?
for example, like students, they get their grades by letters, A, B, C.
Oh, I see what you're saying. You're collecting, but you have to turn each grade into a number. So if you said, oh, but here's the deal, is there A minuses involved?
Yes.
Okay, we're gonna turn every one of those letter grades into a number that represents that grade. For example, we'll give a 4.0 for an A. A minus, we're gonna give a 3.7. I'm answering my own question. B plus, we're gonna give a 3.3. Are you collecting discrete or continuous data? Continuous, because when we transfer those letters into numbers, we got decimals involved, and that's why it's continuous. When we transfer these responses to numbers, and got 1, 2, 3, or 4, there was no way we'd ever get a 2.2 or 2.3, and that's why that was discrete. But if any of the words have to be transferred to numbers in between the numbers, turns into continuous. How do we feel? We can identify what kind of data we're collecting from a question. Oh, this quiz is gonna be too easy. I now have to write a harder quiz just because of this. What?
No, it's already hard.
Oh, stop, you guys. What's your average grade on your in-class assignments? 99.5? Right? What's your average grade on your homework? Well, that's only your second one. You are doing the work that's not that hard to keep your grade up, because, you know, don't expect to get 100 on this first quiz. Don't get me wrong, it's your easiest quiz, but I gotta make it challenging, you know? And part of the challenge is the time constraint. And how do you prepare for this quiz? You gotta figure out how to be so organized that when you read a question, you know exactly where to look to get the help you want. That's how you prepare. Where are you gonna find the place to look? I don't wanna, I'm gonna be walking around looking over your shoulder the whole quiz, and it just breaks my heart when I see a student just searching and searching and searching as that clock is going by, because they didn't have a system to know where to look. All right? That breaks my heart, because I know you're gonna be guessing to get things finished at the end, because you're gonna run out of time. And you're teaching yourself everything right now on the spot while you're taking the quiz. It's a common thing. I think that's all I got. Any questions at all? Are we good? Can we go home? All right, let's do it.